Welcome to Networks Professionals.
Hey everyone, welcome back to the Explainer. So, if you're managing traffic on a router, you absolutely need a foolproof way to control who goes where, right? Well, today we're mastering foundational network filtering through standard access control lists. We're going to cover what they are, how they tick, and crucially, how to deploy them without accidentally locking yourself out of your own network. Okay, let's dive right into this. Imagine you need a strict, unyielding guard for your network. You really don't have time to inspect every single detail of a visitor's paperwork. You just want to check their ID, see where they're from, and make a split-second decision. Let them in or drop the gate. So that's our scenario today. How exactly do you efficiently drop a massive roadblock using just a single line of logic? Well, to answer that, we really have to look at the absolute core limitation and honestly, arguably the core strength of standard ACLs. It is all about the source IP. And that is literally it. Standard ACLs cannot inspect destination IP addresses, they can't look at protocols like TCP or UDP, and they completely ignore port numbers. They have this absolute tunnel vision. They only care about one thing: where did the packet originate? So because they lack that granular control, they're used pretty broadly to block or permit entire networks or maybe specific host addresses from reaching a destination. You aren't using this tool to surgically block one specific web app while allowing another. No way. You're using this to say something like, the entire accounting department network is denied access here, or this specific server IP is permitted. It's kind of like a blunt instrument, for sure, but an incredibly powerful one when you use it strategically. All right, so what are the 4 rules of the game here? Let's take a quick look at the specific parameters that really dictate how this particular network gatekeeper operates. First, as we just established, it's entirely source-based. Second, when you're actually configuring these, they use very specific numbered ranges. We're talking strictly between 1 and 99, or the expanded 1300 to 1999 range. Third, if you're like me and you totally hate remembering arbitrary numbers, you can actually use named ACLs for easy alphanumeric identification. And fourth, well, this fourth one is a bit of a trap. Yeah, the hidden trap here is the implicit deny. What's really interesting and kind of scary about this is that at the very bottom of every single access control list you build, there is an automatic, completely invisible deny all rule. Basically, if a packet doesn't match any permit or deny rule that you explicitly wrote out, it just hits the bottom and drops dead. If you forget about this invisible rule, you're going to accidentally lock out legitimate traffic, and I guarantee you'll be getting a miserable 3 a.m. troubleshooting call. Nobody wants that. Now, understanding the rules is one thing, right? But execution is a whole different beast. And that brings us to strategic placement. Think about it. Where exactly should we station a guard who only checks where traffic originated from? Let's see how this builds into our overall placement strategy. There's a golden right way and a very wrong way. The right way? Always place standard ACLs as close to the destination as possible. Doing this absolutely prevents you from accidentally blocking traffic that's actually meant for other networks. Now compare that to the wrong way, which is putting it right at the source. If you drop a standard ACL right where the traffic originates, you literally ground that traffic before it even has a chance to route anywhere else in your network. So always remember, put it near the destination. Okay, so we've got the theory down, and we've nailed the placement strategy. Now let's switch gears, talk execution, and actually configure your router. I know command line syntax can feel a bit overwhelming. So let's just break the execution down into 2 super straightforward steps. Step 1, you create the ACL itself, essentially laying out your list of rules. Step 2, you take that list you just built and you apply it to an active interface. Because honestly, an ACL just sitting in a router's config does absolutely nothing until it's actually attached to a doorway. So for that first step, the syntax is actually pretty logical. You just type access list, followed by your chosen number, say something from that 1 to 99 range. Then you dictate permit or deny, type out the source IP, and finally add your wildcard mask. And as you probably know, a wildcard mask is really just the inverse of your standard subnet mask. So for example, if you're in global config mode, you might create access list 10, tell it to permit the 192.168.1.0 network, and use the wildcard mask 0.0.0.255. Boom, your rule is officially created. Now to complete the whole process, you've got to move into an active interface. The command here is IP access group, followed by your list number and then the direction, either in or out. So if you type something like IP access group 10 out, you've just successfully attached your gatekeeper to the door. You're actively instructing the router to filter all outbound traffic against that access list 10 you just made. Of course, building networks can get incredibly nuanced, right? And let's be real, sometimes things just don't behave exactly as you expect on the very first try. So for deeper troubleshooting steps and way more detailed syntax breakdowns, the absolute best resource you can reference is the official Cisco IP Access List Guide. It is literally the definitive manual for navigating all the little quirks of Cisco iOS filtering. Well, look at that. We've basically mastered the standard ACL. We know exactly how to block an entire network by looking purely at its source IP. But, this kind of leaves us with a critical, looming question for our overall network security. Think about it. If standard ACLs only check the source, how in the world do you filter based on the destination? How do you go about blocking a specific protocol? Well, that requires a totally different tool entirely, and is exactly what you should be investigating next. Thanks so much for joining me on this explainer, and I will catch you next time.
Thanks for watching.